Okay, so we're going to go over transformation of functions. They've given us the parent function. F of x is equal to x squared, which is just a normal parabola, okay, drawn on a graph where the vertex is at the origin. Here is all of the transformations we can have, where A is vertical stretches, K is horizontal stretches, D is horizontal translations, and C is vertical translations, okay? So what we're going to do is just underline which we have of which. So for A is represented by 0.5. K is represented by the number 3. D is represented by 4. And C is represented by -1. Okay? So we have quite a few translations here. So we're going to bring up a graph. Okay, so what we'll do is we'll draw the original graph. So the original graph for f at x is equal to x squared is just a parabola, right? So we know the origin's at 0 and 0. We go over 1 up 1, both ways, over 2 up 4, both ways, over 3 up 9. So when I try to connect the dots, we have something that looks like this, right? Okay, so let's talk about the very first one. We're going to talk about A. A is a vertical stretch, so we're talking pulling it up and down by a factor of 0.5. Okay? So in other words, what we can do is we can take our major points here. Okay? Now, this will not affect our vertex on this one, and same with K not affecting our vertex. Okay? So we don't have to worry about those two affecting the vertex, but we knew that they will affect all the other points. So a couple of the points we have 1 and 1, we have -1 and 1, we have 2 and 4, and we have -2 and 4. Okay, so since A deals with vertical stretching by a factor of 0.5, what we'll do is we're going to actually multiply our A value by all of the Y values of these coordinates. Okay, so this 0.1 I'm going to multiply by 0.5. This, sorry, not 0.1, the 1. Same with this 1. Same with this 4. Same with this 4. Okay? So then we'll get an idea of what it's doing to the total graph. So our new points, obviously our x's will all stay the same. That's supposed to be a 1. There you go. This one's supposed to be a -1. This one will be a 2. This one will be a -2. Okay? What will the new y coordinates be? We're going to get, yeah, 0.5 is one of them. Yep, I know it's a little squished here. Yep. Yeah, that's right. Okay. So our new coordinates, we go over 1 up 0.5, over 1 up 0.5. There's a new coordinate. Vertex is still at 0. And you can think of it being as when we multiply 0 by 0.5, it still stays at 0. Okay. And when we go over 2, we go up 2. Okay. Essentially what we're doing, if you notice, is we're going up half as far as we used to. I used to go up a whole 1, now I only go a half. I used to go up 4, now I only go up 2. So instead of going up 9, how much would I go up for the next movement? Yeah, 4.5. So it would be somewhere like this. And I can even get the next one in. When I go over 4, for the black parabola I've drawn, how high up would it go? Do you know? Well, because we did 3 squared is what gave me my coordinate for 9. So when I go over to the number 4, I square 4. That's right. But since we're multiplying by 0.5, my red parabola, which I'm about to draw, what would the next point be? Instead of 16, it'll be at what? That's right. So we'll have something around here. So this is the first movement, okay? So this is just A. So we take a look at this, and we have a wider parabola for this one to start off. Okay, the next thing we're going to talk about is our number 3. 3 deals with our K value. Now, what we did here is we multiplied our Y by the absolute value of A, okay? What we're going to be doing for K is we're going to be multiplying our X values for those new coordinates we have, okay? So we're going to be working with the new coordinates. I'll put them in red. Again, we had 1, 0.5. We had -1, 0.5. And you know what, I might as well do them all, the ones we have. 2 and 2, -2 and 2. We had 3 and 4.5, negative 3 and 4.5. And we even had 4s, right? 4 and 8 and negative 4 and 8. So we have, again, our x and our y values. So the last one we did affected our y's. This one is going to be our k affects the x values in all of these coordinates. But remember, we don't multiply by the absolute value of k. It's something very different. Do you know what it is we multiply by?
1 over k.
Yes, we multiply by 1 over k. Okay? So because we're multiplying by the absolute value of 1 over k, we're going to be looking for 1 over, what was our
3.
k value? Yes. So we're looking for multiplying our x values by 1 over 3. Okay? So our new coordinates, what's my x value going to be in my new coordinate?
0.
We can leave it as a fraction.
Oh.
So what's 1 times 1
1
third?
over 3.
Yeah, 1 over 3 and 0.5 for our y value. Okay. What about negative 1?
Negative 1 over 3.
Yeah, and I'll just fill in the y's. You tell me the next one.
2 over 3.
Yeah, that's right. 2 over 3 and 2.
Negative 2 over 3.
Yep. And 2.
Is it just 1 or 3?
Yeah, that's going to be 1. 1 and 4.5. And, yeah, 4.5. Okay. And what about our next ones?
1 and 1 over 3?
Yes, 1 and a third or 4 over 3, that's right. So you can say 1 and a third and an 8 and negative 1 and a third and 8. Yeah, you're right for our coordinates. Good. Now, if you know these are all fractions, so we're going to go up. I know we can't see them exactly. Where our new coordinates have, everything is going to have shifted inwards, okay? These things are shifting inwards. They're all coming in a lot farther than where they used to be. So what I'm going to do is I'm going to focus on a couple of them. And what I'm going to focus this on is our 1 and 4.5, negative 1 and 4.5, just to get an idea of what they're doing, because at least we have one whole number we can really work with, right? So we used to be at 4.5 here, and that was 3 and 4.5, right? It's now been shifted inwards to 1 and 4.5, okay? Same with the other ones, been shifted into 1 and 4.5. Our vertex is still here, okay? So everything's being moved in by a third, okay? We're dividing each of our x values by a third. So we got over to 3 as one of them, and that came over to 1. So if I happen to get over to 6, now this one's a bit of thinking, okay? 6 squared for our normal black parabola would have gave me 36. Well, remember, we multiply by the value of a, which was 0.5, which would have gave me, do you know what number? 18, okay? So what that's saying is 6, okay, I want you to think about this. If I'd multiply 6 by 1/3, what would that point now be? 2. So here's 1. At 2, I would be at the y value of 18. So I have a very thin parabola now, okay? So what's happened, so it goes up something like this. Blue's our second one, okay? So we have, this was a whole number, than 1. So our k value is larger than 1, okay? So this was a horizontal compression, which kind of makes sense, okay? If you take a look at it, we went from the red to the blue. So it's like someone squeezed the parabola horizontally. They've made it thinner. And for our a value, this was technically a vertical compression. And think of it like here was our old parabola, and something came down and squished it so it got wider. That's where we went from our black one to our red one. Okay? That's how we got a vertical compression. So a vertical compression and a horizontal compression to our parabola look kind of different. They're two kind of different movements. Okay? Now, this one we can do without going through all the points. Okay? What I want you to look at is our d value. Okay?
Wait, so when you're graphing.
Okay, the next two are a little easier once you do the compressions and the stretches. D. Now, we talked about this the other day. Technically, that number in there is -4 because our parent function is x subtract whatever d is. So if d was -4, oh, sorry, it was +4. When we plug positive 4 in, we get x minus 4. Okay? But an easy way to remember is just look at both of them. And because we have negative 4, horizontally, we go in the opposite direction of a negative. So negatives normally go left, so we're going to move this whole parabola to the right. So the blue, we're going from the blue again, okay? From the blue, we take each of these points and move them 4 to our right, okay? So the vertex is now at the number 4. My 1 in 4.5 now moves over to 5 in 4.5. My negative 1 in 4.5 moves over to 3 in 4.5. And that's pretty much it in terms of how many we can fit on this graph. But this is with the D translation. Okay. And finally, the very last one, we'll have to do black again because I don't have that many colors, is our C. And our C deals with vertical translations. And because it's negative 1, since C is equal to negative 1, we just shift the entire parabola down 1. So my vertex is now down here. This point goes from 4.5 to 3.5. And we have a thin parabola that looks roughly like this. Now I know there's a lot going on in this page, but our black one is our final one there. And it has a coordinate here of 4 and negative 1. It has another coordinate here of 5 and 3.5. And that other coordinate there was 3 and 3.5. Okay, way up there. So there's a lot of different translations that can be made to this. Let's take a look at the entire page. Okay, so there's a whole lot we did in order to figure all of those out. Another way you could have solved these, if you're unsure about the D and the C, usually they're a little more visual so people find them easier. You could have took the D value and just added 4 to any of the X values of our blue one. Okay, and what we really did is we focused on the one of 1 and negative 1, and those were the only ones I really added 4 to. So when I had, see how I had positive 1 there? We did 1 plus 4. That equaled 5, right? And that's how I got this x coordinate of 5. And when I had negative 1 plus 4, I got 3. So that's how I got this other coordinate of 3 and 3.5. Okay? And same with our C value. We would have taken, again, we're only focusing on these 2 points, our y values of those coordinates. And when I subtract 1 from each of them, 4.5 subtract 1 gives us 3.5. So that's how I got 5 and 3.5 and 3 and 3.5. But they are a little more visual, so people usually can make them just by looking at the graph. But if you needed numerically how to do it, that's how you add them or subtract them to the coordinates. Okay, so we're also going to graph this function here. And I just want you to quickly think about it. What this is when our x value is a number, we're just going to put arbitrary x numbers in. What will our y value be? That's how we can quickly graph this. Okay? Because there's no other translations, this is a pretty standard graph to draw. First of all, can I put an x value of negative 1 in there? Put negative 1 under the root, so can I get the root of negative 1? No, I can't find the square root of negative numbers. So right away, everything to the left is not going to exist on this graph. So I already know I don't have to start there. So I can start with a very basic one, square root of 0. I knew that would do that. What is the square root of 0? 0. So in other words, when I put in, I'll make a little t-chart for you. Okay. This was our x and this was our y. When I put x at 0, y was 0. So one of the coordinates is 0 and 0. That gives me a coordinate. What about when I put in the square root of 1? So I have a coordinate of 1 and 1. Now, I could put the square root of 2, but I'm going to get an odd number, right? So let's just try to stick to points that will give us whole numbers. We can definitely do it, but it'll be hard to graph because it's going to give us a large decimal. So what's the next smallest number we know we can get an even root out of? 4. So let's put in when x is 4, what is y? 2, that's right. So we go x4, y2. Oh, you know what? I drew the first point wrong. It's too high. There you go. And this should have been there. Okay. What's the next number we can find a root of? 9. That's right. What's the root of 9?
3.
Yeah, that's right. So there's another one.
It's the same as x cubed?
Yeah, it's just upside down. Now.
Wait, how's it upside down?
Well, sorry, sideways. Okay. Our old parabola. Now, here's a major point. I do want to talk about this with the roots, but because I think they only want functions, you're only doing the top half. Technically, the square root of 1 is plus minus 1. because I can multiply positive 1 times positive 1 and get positive 1. Or I can multiply negative 1 times negative 1 and get positive 1. Both of those are true answers. So in other words, technically, I have another point down here, just like I do with 4 and just like I do with 9. So this is kind of like a sideways parabola, where in our last one, our parabola kind of looked like this. This gives us a sideways looking parabola, right? Well, because it's a function with our vertical line test, a vertical line can't go to two of the same points, otherwise it's not a function. So when we go to draw this, we are only using the positive values when we're doing it. Okay? That's what your class might do. Now, if they decide to use both values, and you get a sideways looking parabola, that's fine. And we can shift this pretty much the same way we have done the other one. Let's just do a quick comparison to squared function, right? So we have our x and our y values again. Again, I'm going to again put in x values, right? I'm putting arbitrary x values just like I did over here. I started at 0. Another reason I'd start at 0 because it doesn't exist this way on the graph. And I just found my y coordinates. So I plugged them into this function. I plugged in 1, and then I plugged in the root of 4. Then I plugged in the root of 9. Okay? I'm going to do the same thing down here. But again, we'll start at 0. Now, what is 0 squared going to be? Yeah, that's right. So we know we're going to get that. What about the number 1 squared? That's 1. What about the number negative 1 squared? Yeah. Okay. So I want to show you this is 3 coordinates right now. Now I didn't go in order the way I'd done in the other one. But here's a 1 point, exact same point they have over there. That was the first one. Our next point is at 1 and 1, so I go over 1, up 1. Oh, another point that looks roughly the same. Here I get negative 1 and 1. Well, that definitely didn't exist on our other function. My x value is negative 1, and my y value is 1. Okay. What about the number 2? Well, 2 squared will give me 4. And same with the number negative 2 will give me positive 4 again. So I go over 2, up 4. I go to the left 2, up 4. And again, I'm starting to get a shape that looks more like our old parabola. Okay? So it is different than our root function that we're dealing with here. If anything, if I had filled in the spaces like this, it looks like a sideways parabola, as if somebody has twisted this on like a 45-degree angle. Okay? So that's kind of the difference between the two. Now, since we're about to transform this function, I'm just going to erase our parabola off of the grid just so we have a little more room to make sense of it. Okay? But that's what the differences are between those. Put this back. So now we got our function. Okay, so they have this transformation here for us. Okay, so I'm going to quickly write in our letters here. Here's our a. What's the value of a? Yeah, so it doesn't change anything. Here's our k value, negative 1/2. Our d value is our 4, and our c value is 3. Okay, so because our a is 1, I have to do nothing to this graph. Okay, and what I'm going to do is I'm going to just write the points down again, those coordinates in black here. So I have the coordinate of 0, 0. I have a coordinate of 1, 1. I have a coordinate of 4 and 2. And I have a coordinate of 9 and 3. Okay. Now my k values. Remember we said when you multiply k, we go 1 over k is what we truly multiply by. So in other words, we reverse this fraction. So it then becomes 2. Okay. And it's the absolute value. We'll talk about the negative after, or we could multiply by the negative value actually. Yeah, let's do that. Let's multiply by the negative value also. So we're going to take all of these x values and multiply by the number negative 2, okay, because we multiply by the reverse of what's in there. So our new values are going to be, well, what's 0 times negative 2?
0.
Yeah, so that's not going to change anything, right? What about 1 times negative 2? That's right, so negative 2 and 1. 4 times negative 2? Negative 8 and 2. And 9 times negative 2? Yeah, 3. So our new coordinates after the k, so this is only the first one. I have 0 and 0. I have negative 2 and 1. I have negative 8 and 2. And the other one's not even on the chart. So what I have is something going like this. Now we're going to zoom up just a little. So in other words, this is what's happened here. We've had a flip on the y-axis, okay? And we've had a horizontal stretch. So this used to be like this. It's now been pulled farther out. So think of like someone has stretched it, so it becomes a smaller, thinner one with our horizontal stretch. Where a horizontal compression would be like if we had two walls coming in on it, and as they compress, this would go higher up here because it would be getting flatter and flatter as it comes in. Okay? But a horizontal stretch, say we have this shape here, and we pull the walls out, well then the walls are out here, and we have something that's thinner than before. So this one's a little thinner or lower down than our old one. Not by much, okay? But it is. But that's only our K movement. Now we have to deal with our D, which is positive 4. If this entire little operation here is positive 4, what does it mean? Which direction do we move?
Left.
Yeah, we move to the left or in a negative direction by the number 4. So again, I'm going to take those coordinates we've written down in blue here. 0, 0, negative 2, and 1. So 0, 0, negative 2 and 1, negative 8 and 2, and negative 18 and 3. Well, negative 18 and 3 is not even on this chart, right? So next thing I'm going to do, because D again deals with X, I'm going to subtract 4, because we're moving in a negative direction, from all of those values. So my new coordinate, 0 minus 4, will be negative 4 and 0. Negative 2 minus 4 is negative 6 and 1. Negative 8 minus 4 is technically negative 12 and 2. That's not even going to be on our chart anymore. Okay? So I'm going to jump up. I'm going to be at negative 4 and 0, which is here. Negative 6 and 1. Negative 6 and 1, that's here. The other one would be negative 12 and 2, so it would be out here. So here's our second movement. We've translated it 4 units to the left from the old one. That's going from the blue to the green. So we've gone from the black, which was higher up, to a thinner reversed blue. And now we've shifted the blue 4 to the left. And finally, for our C movement, this one actually affects all of our Y values. So I'm going to take all of the Y values in this, and I'm going to subtract by 3. So my new coordinates will be negative 4 and negative 3, negative 6 and negative 2. And the one that's not really even on it would be negative 12 and negative 1. So we take a look at this, and everything gets shifted down 3 units. So I'm at negative 4 and negative 3 now. Negative 6 and negative 2, and 12 and negative 1. So this guy has been shifted down from the green one 3 units. So we went from the original black to a thinner horizontal stretch and reverse, so reflection on the y-axis. Then from the blue to the green, we translated 4 units to the left. And from the green to the black, we translated it 3 units downward. So this is our final graph now. Quite a bit of work. But we could always do it by just plotting our coordinates and multiplying by numbers to figure out our